it's Jay, and today we're going to be taking an in-depth look at motion constraints in Autodesk Inventor 2021.
Alright, so where are you going to go to find the motion constraints? Well, they are constraints, so you go to the constraint menu. However, instead of being under the assembly tab up here, they're under motion, which makes sense, because that's what they are. And speaking of that, what are they? So basically, they're very different from other constraints because instead of forcing something to not move, it forces it to move, which may sound really strange at the moment, but it'll make sense at the end. Basically, there are two types of motion constraints in Autodesk Inventor. We have rotation and rotation translation. Rotation translation is a bit less useful for FRC than rotation is, but we'll still go over it a little bit so that you know how to use it. So basically, if I go to chuck these gears on this here piece of Versa frame, just so we can demonstrate, sure, it's fine. And then I ground the Versa frame so that it can't move at all. We can see that when I rotate one gear, and I grounded the gear, that's the thing you have to be careful of. When you go to ground something, it grounds whatever is selected, not what you right-click. Oh, it's grounded as well. Sweet. Apparently grounded both. Basically, you can see it rotates one wheel, but this thing does nothing. And that's where the rotation motion constraint comes in. Has two options here. We have forward and reverse. So we're going to start with forward. Basically, what forward does is it will rotate a second object the same way you rotate a first object, like wheels. So if we do that, then we apply this, we kill this. Now they rotate in the same direction like the wheels that they are, which makes perfect sense. And then if I open this back up and edit it, we can see that we have a ratio, right? And right now it's 1:1. And if I go to make it so 0.25, one of these is going to, the second one is only going to make it's only going to make a quarter rotation for every full rotation of the first gear, of the first wheel. So this is super useful when we get to the second kind of rotation constraint, which is reverse. Basically what this will do is it allows you to constrain two objects to rotate the opposite direction of each other, like gears, which is coming back to how I said that ratio is going to be useful. You know how gears have ratios? You can just plug that right in there and they'll rotate and they'll still be like mesh teeth the whole time. And it's great because you can just treat them like gears and it looks all nice and fancy. So, and then if I go ahead and delete all of this, because we don't need them right now, and then unground this because I'm setting up for the other kind of constraint just so I can demonstrate it a little bit, because it's good to know if absolutely nothing else so that you know what's going on in your software and you don't know, ooh, I don't know what that button does. So basically then, okay, we're almost done. And then there, so now we have this all set up. Basically, the second motion constraint is rotation translation. So what you think is when you rotate something, it'll translate something. It doesn't do that. It's when you translate something, it'll rotate, which is a little less useful, like I said, but still cool. So like if we go reverse, when we slide this up, it'll rotate. You can see these arrows in these pictures. They're pretty clear. I think it makes sense. Basically, yeah, you can see when this goes this way, it'll rotate that way, and when this goes this way, it'll rotate that way. So the first one you're going to select is a face that's going to rotate, and then you're going to select some vector axis that will translate. So I select this, then we apply it. You can see, which sadly, when I rotate this doesn't translate, make it a lot more useful. But when I slide this will rotate, and yeah. And obviously this has a, whatchamacallit, there it is. This has a distance option that you can change. So basically what this means is for every 1 inch that this moves, this will do one rotation. So if we say change this to 10 inches, now we have to move this 10 inches for one rotation, so you can see it rotates much, much slower. And that is basically how you use them. So obviously, the use cases of motion constraints are a bit different than some use cases for most other constraints. You don't really use these in like rough trial, make it see if it's gonna work CAD. You really only are gonna use them in like really detailed CAD that you're showing off specifically at a computer to demonstrate. And some of it, yeah. And basically they're less useful than a lot of other constraints, but they're really good for making your CAD look really nice at the end. So some things you got to be careful of with this is you have to make sure you have the right thing selected, because there are a lot of different options here. And you have to make sure that all of your other constraints allow for these motion constraints. Like, for example, many motor shafts, like you get the CAD of a motor, the shaft won't rotate independently because it's part of an assembly, and Inventor treats them as one thing when you import them into a larger assembly. And ideally, the motor won't just straight rotate, because hopefully you put in at least 1 or 2 motor bolts to hold it in place. So that would basically, it would let you put the constraint on, but nothing would turn because that couldn't turn. So that's just another thing you got to be careful of. And yeah, that's pretty much motion constraints. I'll see you guys in the next one.